In this question from the chapter derivative, we are given, this is one of the question that is tested in board examination 2024. We are given if x is equal to 1 minus x square plus under root 1 minus y square is equal to a bracket x minus y, and we have to prove dy by dx is equal to whole under root 1 minus y square over 1 minus x square. Now, in order to solve this, we'll be using the property of C and D, that is cos C plus cos D and sin C minus D. Now, before that, what we are going to do is first, let's say, assume, let's take, I'm taking here, say x is equal to sine alpha. We'll put x is equal to sine alpha. That implies alpha is equal to sine inverse x. And we are also going to replace y with, say, sine beta. That means beta is equal to sine inverse y. Now, if I do so in the question, now our question changes to, I'm writing from the question, this will become, this is on the left-hand side, we are going to get 1 minus sine square alpha whole under root plus whole under root 1 minus sine square beta is equal to a times sine alpha. For x, I'm replacing with sine alpha minus sine beta. Now, 1 minus sine square is cos square, whose under root is cos. Like 1 minus sine square alpha is cos square alpha, and cos square alpha over under root is cos alpha. So we'll get cos alpha from here, and that side we are getting cos beta is equal to a times sine alpha minus sine beta. Now, after further, we can simplify it by applying the C and D identity, which I referred in the beginning. We are going to apply these C and D identity. Let's say cos C plus D. If I apply cos C plus D over here, it is 2 cos C plus D by 2. That means alpha plus beta over 2, and then cos C minus D by 2. That is cos alpha minus beta over 2. That's on the left-hand side. On the right-hand side also, I'm going to apply C and D again. And for this, the identity will be sine C minus D. So sine C minus D is 2 sine C plus D by 2, sine C minus D by 2. So 2 cos C plus D by 2, let's say. So if I apply 2 cos C plus D, which is alpha plus beta, as this is C and this is D here, as per the formula. So that is C plus alpha plus beta over 2, and then sine alpha minus beta over 2. Now what you can see from here, that here we can cancel 2 and 2, and even this get cancelled. So if I transpose this to the left-hand side, so what we are going to get here, cos over sine. So we'll get this as cos alpha minus beta by 2, and that divided by sine alpha minus beta over 2, and that is equal to A. Now I need some space here. Now this is cos over sine. Cos over sine is what? Cot. So we got this as, this I got this as cot in, this is cot alpha, right? This is cot alpha minus beta over 2 is equal to A. So that means we can write alpha minus beta as 2 times cot inverse A. So now I'm going to replace this alpha and beta with sine inverse x and cos inverse x. So replacing alpha, which is as for this, it is sine inverse x. So this is going to be sine inverse x minus beta, which is sine inverse y, is equal to 2 cos inverse A. Now, from here onwards, I'm finding derivative. So if I differentiate both sides with respect to x, so for sine inverse, it is 1 over under root 1 minus x square. For sine inverse y, it's going to be 1 minus y square for y by chain rule. So dy by dx is equal to 0. If I solve this over here, now I'm going to transpose one of them. Let's say, for example, if I transpose this on the other side, is going to be positive 1 over under root 1 minus y square times dy by dx. If I transpose this to the other side, it's going to be under root 1 minus y square over under root 1 minus x square, and that is equal to dy by dx. I can see that this is what we were asked to prove. That is dy by dx is equal to whole under 1 minus y square over 1 minus x square.